folks, welcome back to 10.2, where we're going to be talking about circles and ellipses. So let's take a look at example number 2. So in example number 2, we have something that looks a little bit more like the ellipse formulas we saw in the earlier pages. Now, a few things here. When I look at this, I happen to notice that my a squared and my b squared values are the same. And as we saw in the last example, that means that I'm going to end up with a circle and not an ellipse. So I'm going to go ahead and write that my shape is a circle here. And what I'm going to do is I'm actually going to multiply both sides of this equation by 64. So I'm going to get x minus 2 squared plus y plus 3 squared equals 64. Or I can say that 64 is 8 squared. Now this means that I really have only a little bit of work to do. I know I can find my center by switching the signs of the x and y values. So I have, instead of negative 2, I have a positive 2. And instead of a positive 3, I have a negative 3. And I'm going to go ahead and draw that center right on my diagram. So 2, negative 3. Now, from the last example, I remember that there are no vertices, no co-vertices, no foci for a circle. And so really the only thing left is to figure out how many spaces I need to count from my center. And that number is right here. So it's not 64. I'm not counting out 64 spaces on all sides. I'm counting out the square root of 64, which is 8. So from my center, I'm going to count out 8, and then, this goes off the graph a little bit, and then here, and then here. Now, I find the easiest way to draw the circle is to draw those 4 points, and then just kind of like connect the top half with a half circle. Though, like, you can tell that one's not totally round, and then sort of do the same thing with the bottom half. Okay? I'm not grading you on the quality of your drawing, but I do want you to know what some of those important points are. All right, let's move on to the next example. So, example 3. I notice here that my numbers are not the same on the bottom. One number is a 4, and the other number is a 9. And so what I'm going to do is I'm going to rewrite this equation so that I can see more clearly what numbers are squared on the bottom. So x plus 2 squared over 2 squared plus y minus 5 squared over 3 squared equals 1. Now this is very clearly an ellipse, and I know this because I have a something squared, it's equal to 1, and really important, it's a plus sign here. Okay, now that I know that's an ellipse, my job is to determine, is it going to be a longer one or a taller one? Either way, let's start with our center. Negative 2, positive 5. Okay? Negative 2, positive 5. Negative 2, positive 5. All right, now we're going to find our vertices. Now our vertices are going to be determined by whether we go up and down more or we go side to side more. Now, I know we can all tell that 2 is smaller than 3. So 3 is going to tell us how far we go. Well, it's underneath the y, so how far we go up and down. So from my center, I'm going to go down 3, and I'm going to go to up 3, and those are my vertices. So I can say negative 2 and then comma 5 plus or minus 3, and that will give me negative 2 comma positive 2 and negative 2 comma 8. All right, the co-vertices are going to be 2 units out, sideways because it's underneath the x. So from my pink point, I'm going to go 2 to the right and 2 to the left. So that will mean that I do -2 plus or minus 2, comma 5, and that will lead me to -2, whoops, that will lead me to 0, comma 5, and -4, comma 5. And again, drawing that diagram isn't really about making you do more work, but I really think that it makes it much easier to see what all the numbers are doing in your equation. All right, last part of this question is we have to find the foci. And the way we're going to do that is we're going to use this equation. C squared equals A squared minus B squared. Okay? And one way that I remember it's a minus is because the A is bigger than the C. And so now I'm going to plug in the numbers I have. So A squared is going to be the bigger number, 9. That's the one in the green. Minus B squared is going to be 2 squared, or 4, the smaller number. Okay? So we're really thinking like from the vertex we square that, and from the co-vertex we square that. That's going to give me a c squared of the square root of 5. And, well, not a c squared of -5 of root 5, but a c of square root of 5. Now, that means on our diagram, we're going to go -2 is going to be the x value, and then 5 plus or minus square root of 5. Now, it's probably easiest to graph if you turn that into decimals. So -2, if I do 5 minus root 5, I'm going to get 2.764. And if I do 5 plus square root of 5, I'll get 7.236. Okay? Now I'm just turning those into decimals so I can approximate it better on the graph. So I'm going to go to about 2.75 and about 7.3 something. So those are my foci. And then I'm going to go ahead and outline the entire shape that I have, which is the red to the green to the red, and then red to the green to the red. Okay? And that would be a totally fine diagram. And from my diagram, I can see that it's definitely going to be a Bert kind of ellipse. And I could have predicted that in the beginning because the number under y is bigger. Okay? So that bigger number means it's going to be taller. And if I had a bigger number on the x, it would mean that it was going to be wider. All right. Let's do one more example before we finish off this video, 1 or 2 more examples. So let's take a look at example number 5. Okay, so for example number 5, let's see what we have. Well, I have something that doesn't quite look like the ellipse formula. So what I'm going to do is I'm going to take the equation, I'm going to divide everything by 100. The reason why I'm dividing by 100 is so that I can make this right-hand side equal to 1. That's one of the defining characteristics of the ellipse equation. So then I'm going to get x squared over 25 plus y squared over 4 equals 1. And I might even write that a little bit more for myself as x squared over 5 squared plus y squared over 2 squared equals 1. Now this time I notice that there's no like x minus something or y minus something. That tells me my center is at the origin. I'm going to go ahead and write that up here. My center is at the origin. And I know that this is an ellipse. And the only question is it going to be this one or this one? So let's go back to our equation and see. Well, from my center, I'm going to go to the right 5 units. So from my center, I'm going to go out 5 and to the left 5. Now 5 is bigger than 2. So I'm going to go ahead and guess from my diagram, it's going to look something like this. And so that means that it's going to be more of an Ernie ellipse than a Bert ellipse. But the green points, they tell me my vertices. So 0 plus or minus 5, which will give me 0, comma, negative 5, and 0, comma, positive 5. Now my co-vertices, I'm going to get 0, comma, 0 plus or minus 2, which will give me 0, comma, negative 2, and 0, comma, positive 2. I'm going to erase the vertices because I definitely made a mistake there. Let's do that again. The vertices are going to be 0 plus or minus 5, comma, 0, which is going to give you negative 5, comma, 0, or positive 5, comma, 0. And again, it's easy for me to catch myself when I see the graph because I can count on the graph. I trust that. And so it's like a little bit of a way to double check yourself if you did the right equation or not. All right, so let's deal with those foci. So for my foci, I'm going to need that equation c squared equals a squared minus b squared, because I know that a is greater than, not a, c. And I'm going to plug in my numbers. C squared equals the larger number underneath, so 25, minus the smaller number underneath, or 4. 25 minus 4, that means c is going to be square root of 21. Now, that means that I have 0 plus or minus square root 21, comma 0 for my foci. And to make it easier for myself, I'm going to go ahead and turn those into decimals so that I know where to graph those. And I'll get negative 4.58, comma 0, and 4.58, comma 0. And those will be about here and here, and I can connect my whole ellipse with that sketch. All right. So folks, that's where we're going to stop for video number 2. Come on back for the last video where we're going to go through a couple more types of problems. See you there.